This is chapter 4, part 7. Let me continue with this. This is very, bullet 1 and 2 is basically for readability with it. Two common use styles for placing braces. This is very important. On a line by themselves. You gotta leave these curly brackets that what you're going to see what people always do, and they get really sloppy in their coding with it, is they write, for example, let me do this main that you've been doing this thing. I always start with just a blank curly brackets with this thing. The bad practice of what people do is they take this left curly bracket and they start right there. Well, what's the problem with that? Well, later on, you're going to get into a lot of issues by pairing in your editor. You recognize this is the left and this is the right, and then when you nest in other brackets with this thing, you can see how messy if you don't have that aligned properly with it. You see that? So wherever there's a left bracket, there has to be a right bracket with it. There is the beginning and ending. So you got to keep this best practice with it. It just helps you to maintain some order with this as well. Okay. Using pseudocode to develop, test, debug, and program with it. That's why pseudocodes are false codes. They're just plain English with it. So they're informal mixture of C++ to ordinary language. So a lot of times I want to do some things in here that you can see me do. I'm going to write basic English. I want to walk you through the logic of this thing first before we actually code this thing. Then we talked about the switch statement. So a few things. We talked about the pretest loops. Pretest loops are what? Your if, which is the single statement. Your if else, which is the multiple statements you can actually have in here as well, which is all pretest loops. The third one is the switch statement. The switch statement is an alternative to the if else with it. So when you look at the switch syntax for this thing, here's the switch. You write the word switch, it's reserved, it's curly brackets. And you test the expression. If any of these expressions falls under the value 1, 2, or 3, it comes down to a statement with wherever it fits with it. But the key important thing is every case statement needs to have a break, semicolon. If you don't have a semi-break, semicolon, this thing, and you write this code, let's say this case statement value 1 does not have this break statement, what it actually does is going to drop down to case statement value 2. Until it bumps into a break. The safety net that I want to point out is the default with this thing. You gotta have a default statement with this thing. So the default is equivalent to the if else. The else is that default that actually catches this. Okay. Again, you don't want to avoid any infinite loop when you design your code with this. I'll do a lot of examples in here that you're gonna see. So here's the switch structures with this thing. Here's the break statement. If you don't have this break statement, it's going to come down to the next one is the case value 2. It's going to drop down until it gets to the break with it. Here's your default. This is the default. Remember, default does not have the break to this thing at all with it. Switch instruction, one or more of the statements can follow by a case label. Braces are not needed to turn multiple statements into a single compound statement, so you don't have to do braces, are not necessary in there. When the cases are matched, all the statements all execute until the break is encountered. Okay. Common mistake. Break statements may or may not appear in each of those. So not every case statements need a break. So let's say you want to choose choice 1, 2, and 3. If you choose choice 1, 2, and 3, then it's like all the above, right? So case statements are a wonderful way how to write a lot of multiple choice statements that tests we do with it. Multiple statements with it. So keywords: switch, case, break, default. 4 keywords in here. Okay. Here's an example of a switch statement that's in here. So I'll let you read. This is example 4-21 with it. So you pass the grade in, whatever number it comes out to be, right? So if it's in letter A, it fits in one of these case statements. And if there's a break, it actually outputs what you want it to do with it. Okay. And reminding you, the only one that has the block statements are the curly brackets are outside your case. You don't put curly brackets inside your case statements in there. Let me just revisit a little bit more about debugging with this thing, okay, to output the result correctly with this thing. So consider whether the switch structures, including the break statement, are for the proper C out with it. You know, the thing about terminating a program with an assert function, certain type of errors are difficult to catch, okay, zeroed by. So you take any number that's inside of the denominator is going to be an error with it. An assert function is useful to stop the program execution that prevents you from that runtime error with it as well. So we'll get into, there's one or two expressions that I talked about assert expression in here, but this expression is a logical expression with it, okay. So keep in mind that the expression of values to true, the next statement executes. The expression of values to false, the program terminates and indicates whether the program error occur with this thing. So to use the assert, you got to include the C assert header file on the top. Okay, so this is the assert function that you're going to use with this thing. The assert is useful to enforcing program constraining the program development with it. So again, the preprocessor directive is pound, define, and debug. Okay, so here we go. So I'll let you read the summary, what we talked about. This concludes chapter 4, the lecture notes with it.